Hey guys, happy Friday. Of course, I'm not here today. I am on campus just on meetings all day today, so I apologize for that. So today is basically a second day of review. Remember, yesterday we started our new unit on trigonometric ratios, and again, we were just setting up the problems. We really haven't solved anything. Again, the hardest part for this unit, for this topic, is really just understanding how do you set it up and what's the relationship. Okay, so I want to make sure I review that again today. Several of you guys were absent, so I'd appreciate if you guys work together, help each other out, especially since I'm not there. All right. So again, make sure you guys know the deal, right? Make sure you guys get that title down and follow along. So again, that's basically the idea. Yesterday we said, hey, trigonometry, it's a branch of mathematics that studies the relationship involving lengths and angles of a triangle, specifically right triangles in this case. Now, yesterday I talked about this important little circle here, which is called theta. It has a little line across it, right? It's something that looks like this when you actually draw it yourself. This is what we call our reference angle. And again, everything depends on where you stand. This is where you stand. So wherever that little theta is sitting, that's going to determine what side I called my opposite, my adjacent, my hypotenuse. So again, I cannot stress that enough. That was kind of one of the big misconceptions I saw yesterday. So in this case, if theta is standing right here, then the opposite side is going to be directly across. So again, you notice they go across, across, across. That's what we call our opposite side. All right. Now, the next one I always like to identify is my hypotenuse, because the hypotenuse is always going to be, find your 90-degree angle and you go directly across that one. That's going to be your hypotenuse. Okay. And the last one remaining, of course, is going to be our adjacent. Okay. It's the one that touches the reference angle other than the hypotenuse. Once we label it, it's pretty easy to, again, write those fractions and those, what we call those ratios. Now again, the importance of that reference angle. Notice these triangles are all flipped around, theta's in a different spot, so it does change where you're opposite, your adjacent, your hypotenuse. So let's go ahead and let me label this just one more time. Again, start off with your theta here, your reference angle. So it's in this triangle, it's sitting down here. If I go directly across, that's opposite. So again, I'm abbreviated OPP. Okay. Now let's go across the 90-degree angle. Always across the 90-degree angle, it's going to be the longest side, which we call our hypotenuse. I'm abbreviated hype. All right. And of course, the last remaining side here is going to be our adjacent. It's the one, again, that touches the reference angle other than the hypotenuse. All right. Let's go through it one more time. Right here, reference angle. Directly go across. That, again, is your opposite. Across from the 90 degrees, that's going to be my hypotenuse. And then, of course, the last remaining one here is my adjacent. All right. And the last one here again, reference angle. Let's go directly across. That's the opposite side. Directly across from the 90 degrees is my hypotenuse. Okay. And of course, the last remaining one over here on the side is my, it's hard to write, adjacent. Okay. So again, please be careful where you are standing. That's going to determine what's your adjacent, what's your hypotenuse. If I was to take this theta, and if I was to move it to this position over here, it's going to change what's my opposite, what's my adjacent. And we'll see a few examples here in a second. All right, now remember that this unit, it's talking about trigonometric functions, which are called sine, cosine, and tangent. So again, make sure if you didn't have these, you copy these down. And we have this little mnemonic device. It's a way to remember it, which we call SOHCAHTOA. Okay, so again, remember this. You have to memorize this. Um, it's just like the Pythagorean theorem, the quadratic formula. You have to know this one. SOHCAHTOA. Now, so that's sine. That represents sine, not sin. Sine of theta is going to be, notice here, O and H. So it's going to be your opposite over your hypotenuse. So when I label it, that's where those two numbers will end up going. All right, for cosine, cosine is my A and H, which means adjacent. Whatever my adjacent value is, I'm going to write it over my hypotenuse. And then TOA, which stands for tangent or tan in this case here. Theta is my O, which is my opposite over my adjacent. All right, so let's get to it. What do the actual problems look like that I'm setting up here? Now, again, I'm not solving anything, and we'll talk about that actually on Monday. We'll actually start solving for missing sides, and it'll make more sense what we're actually finding. How do we find a side or an angle and things like that? Okay, so this one says find tangent of Q. So this is our key part right there. And I want to write the ratio, so I need to write that fraction. Okay, make sure it's reduced. And I also want to make sure I give the decimal, because sometimes we'll use the decimal, sometimes the fraction. And I'm going to round that guy to the nearest hundredth. So let's go ahead. Before I even jump into anything, so just to remind myself, okay, what sine, cosine, and tangent. Now let's go ahead and label the triangle. Don't just blindly try to plug it in. That's where students often get confused. Let's stand at tangent of Q. So where's Q? There it is. I'm going to put my reference angle. Okay, let's go ahead and label a few things. Well, directly across, we're going to call that my opposite. So 20 here represents my opposite. I see I have a 90-degree angle, so directly across that one is going to be my hypotenuse. So 52 is my hypotenuse. And the last guy here, 48, is my, adjacent. Look at that, fix that. All right, so I'm looking for tangent Q. So remember that tangent of the reference angle theta is your O over your H, your opposite over, or sorry, your O over your A, excuse me, your opposite over your adjacent. Okay, well, where was I standing for this problem here? For this problem, I was standing at Q. So I'm going to say tangent of Q is equal to, so again, I want to use the actual letter here, is equal to, what's my opposite value I go across? That was 20. Since it's going to be 20, what was my adjacent side here? That is going to be, where'd it go? Adjacent here, 48. So again, this right here, guys, is the ratio for tangent of Q. It's 20 over 48. Or, okay, let me get my calculator here. What is 20 divided by 48? 20 divided by 48 is going to be, so I'm going to also rewrite the decimal form of this. Tangent Q is equal to 0.416. Now again, if I want to round it to the nearest hundredth, I take a look at 1, I take a look at the 6. This is going to round it up to tangent Q. Why did I put theta? Erase. All right, let's go back. Tangent Q is equal to 0.42. All right, there we have it. So again, we're just setting up the problems. Like I said, next week we'll actually start solving for either angles or sides. All right, so I want you guys to take a second, pause the video here, see if you can try this one. It's asking for what is the value of cosine of A. Okay, so okay, you're going to be using that middle piece there. All right, take a second, pause the video. When you're ready to go, hit play. All right, so where was I standing for this one? Cosine A, so A is where my reference angle should go, my theta. So there we have it. Let's go directly across. That is my opposite. Okay, directly across the 90. That is my hypotenuse. And last man standing here is my adjacent, that A. Okay, cosine. Well, cosine theta, what is that trig function? Cosine is A over H, which means my adjacent over my hypotenuse. Okay, now let's actually make sense with this problem. I'm not standing at just a random theta. This is cosine of A is equal to, what's my adjacent side? Where'd it go? That is 8. And what's my hypotenuse? That was 17. So there we have it. That is the ratio for cosine of A. And like I said, we also needed to get the decimal here. If I do 8 divided by 17, my handy dandy calculator, we're going to say cosine, what am I doing? Cosine A is equal to 0.47, and the other one's a 0. So I know this one's going to stay as 0.47. All right, next one here. Okay, take a second. Same thing, guys. I honestly just want you guys practicing, making sure you have this down. I don't want this be the reason why you can't get the rest of this unit down. This is the foundation, and it's very important. So again, take a second, pause the video, please, try it on your own. When you're ready, hit play. All right, so find tangent of R. So tangent of R, okay, let me write memorize this, get this tattoo. This might be my next tattoo, actually. All right, so tangent R. So where's R? R is right here. That is my reference angle. Let's go ahead and label a few things. Again, directly across my reference angle, that's my opposite side. I found the 90-degree angle directly across that one is my hypotenuse. And then the last guy right here is going to be my adjacent. Adjacent is the one touching the reference angle other than the hypotenuse. Okay, so tangent of theta, if I take a look at my little mnemonic device here, my little way to memorize it, tangent is opposite over adjacent. All right, so now if I'm talking about tangent R, for this specific triangle, if I'm here at R, use a different color, what is my opposite side? That was 12. And what was my adjacent side? That was 5. So be careful the way you write it. It's opposite over adjacent, opposite over adjacent. So it's going to be 12 over 5. Okay, that's one answer I'm looking for today. Or we can say tangent R is equal to, what is 12 divided by 5? That's going to be 2.4. All right, so there we have it. All right. Okay, take a second, try this one out again. Okay, so let's go through it. Sine, what am I doing? What am I doing? I'm messing up here. Erase, 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 erase. Let's go back. Sorry about that. So, All right, so sine of D here. So let's go to D. That's where I'm going to put my reference angle. Label everything real quick again. Directly across. Whoops, that's my opposite across my 90 degrees is my hypotenuse. And then the last guy here is my adjacent. I always personally like to leave adjacent to the end because I think these guys are the easier ones. All right, let's go ahead. Sine of theta. So what does SOHCAHTOA say? SOHCAHTOA says it's going to be your opposite over your hypotenuse. That's the ratio. That's the fraction that I need to write here. So let's go ahead and put sine of D is equal to, what's my opposite side? That is going to be 7. And what's my hypotenuse? That's going to be 25. So this should be 7 over 25. Or sine D is equal to, what's 7 divided by 25? 0.28. No rounding required right there on that guy. All right, so there we have it. Okay. Last guy right here. Now notice on this one, I ask you guys to calculate two different things, right? Ready? Tangent of A and tangent of B. What you're going to have to do is do the first part, label everything just like we've done in the previous examples, and then you're going to have to reset the entire problem because you're no longer going to be standing at A, you're now going to be standing at B, and you'll see how it affects what's your opposite, what's your adjacent. So take a second, try it out, and then hit play. All right, I'm almost running out of time here, so I'm going to kind of rush through this. I'm going to label a few things here quickly. All right, so for this first part, I kind of quickly went through and labeled everything. I'm just going to do the first one here, tangent A. So I was standing at A, that's my opposite. 15 was your hypotenuse and 9 was your adjacent. And again, tangent, if I look at SOHCAHTOA, it's my opposite over my adjacent. So when I go ahead and I write this, what was my opposite? It was 12, and my adjacent was 9. So I'm going to write tangent of, where was I standing at? Angle A is equal to opposite, which is 12 over 9, or what is 12 divided by 9? Or tangent A is equal to 1.33333 and repeats. So we're going to leave it like that. Okay, so take a second. This is where I want you guys to reset the problem and then try it for tangent B. So I'll show my work here in a second. I'll pause the video to erase a few things. All right, guys, so I went ahead and I labeled a few things. So again, I was standing on this one at B, so I went to B. That was my reference angle. Now notice how this kind of flipped my triangle around, because if I go across now, 9 was now my opposite. Okay, if I go across my 90 degrees, well, 15 still stayed as my hypotenuse, right? It's the longest one. But now 12 was my adjacent. So even though I'm still using tangent here, still opposite of adjacent, it's going to kind of flip the way that I write my ratio. So tangent B should be opposite, which is 9, over my adjacent, which is 12. And then, of course, if I get the decimal, I believe it's 0.75. So there we have it. All right. So again, the reference angle, that's the big difference that it makes where things go. All right, guys, you have 4 problems here. your job. Again, complete them. Check your answers with a sub. If everything's perfect, please turn it in the inbox. Have a great weekend. I'll see you guys on Monday.